this one, react with water, dissolve in water to give a solution of chloric 1 acid, this, with ratio 1 to 1. Then the tablet dissolve in water releases chloric 1 acid, and then react with acidified Ki. Ki react with HClO, which is an oxidizing agent, which oxidize Ki or I minus into I2. And then the I2 produced from the reaction of the solution of the tablet, which contains HClO with Ki, that releases I2 or iodine. We titrate with sodium thiosulfate in this equation. This is the concentration and volume of S2O3, 2 minus, and chlorosuccinamide in water release HClO. Here the equation, ratio 1 to 1. This is chloric 1 acid. The chloric 1 acid, then we react with Ki in redox equation. In redox reaction, HClO is reduced to BCl minus. Ki or I minus is oxidized into I2 times 2. The charge is minus 2, so we add here with 2 electrons. To balance the reduction, this is the reduction, this is the oxidation. The side that the side that lack of oxygen, we add with H2O. So add 1 H2O here because we need 1 oxygen on the right hand side. And then the H become 2 times 2, the Cl become 2, the O become 2. So once again, we adjust. The number of H2O is 2. The number of Cl minus is 2. Then the number of H right now on the right hand side is 4. So the left hand side is lacking of 2. Then we add 2 plus, 2H plus. Then we balance the charge. This is plus 2, this one is minus 2, by adding electron minus. So the side that that need the electron minus is this one. This is 2 minus, this is 2 plus. So we add 4E minus to be 2 minus. Then we have 2HClO plus 2H plus to be 2Cl minus plus 2H2O plus 2E minus. For the oxidation, 2I minus to be I2 plus 2E. This is 4. Then we make the same, the number of electron by multiplying by 2. Then we discard this number of electron. So we have the equation 2HClO plus 2H plus 4I minus to be 2Cl minus plus 2H2O plus 2I2. The number of I2 we find out from the reaction with sodium thiosulfate. The sodium thiosulfate is 6 cm cube and the concentration is 0.005. So number of mole of S2O3 or thiosulfate minus 2 minus ion is molar times volume. The molar is 0.005 times the volume is 0.006 dm cube. So you have 3 times 10 to the power of minus 5 mole of thio. Use this equation. Then we find out the I2 is 1 over 2 because the ratio is 1 to 2 times 3 times 10 to the power of minus 5 mole. So the number of I2 is 1.5 times 10 to the power of minus 5 mole. This is the I2. So here you have 1.5 times 10 to the power of minus 5. Then we move to here. The focus is HClO. HClO in ratio 2 to 2. So 1 to 1. So the number of mole of HClO is the same. 1.5 times 10 to the power of minus 5. Then from this equation, the ratio of HClO to N succinamide is 1 to 1. So N succinamide the same. The N is 1.5 times 10 to the power of minus 5 mole. Then we find out the MR. The MR from the structure like this. You have NCl here. Each angle is carbon. So this structure actually like this: C, O, N, Cl, C, O, and here carbon is in group 4. So the valence electron is 4. So still there are 2 pair of electrons which bonded to H. So the molecular formula is C 1, 2, 3, 4. For the number of H is 4, the number of O is 2, the number of N is 1, the number of Cl is 1. C is 12, H1, O 16, and 14, the AR. Cl is 35.5. Then we calculate the MR is 4 times 12, 48, plus 4 times 1, plus 2 times 16, plus 14, plus 35.5. that is 133.5. The number of mole is 1.5 times 10 to the power of minus 5 mole. This is the N. So the mass is N times MR. 1.5 times 10 to the power of minus 5 times the MR is 133.5 times 1.5. We have 0.002 grams. That's the number of mass of N-succinimide in one tablet. For number 4, this is much more simple. You can calculate by yourself. Here we have the reaction between sodium and carbon dioxide to produce sodium carbonate. The question is the mass in grams of Na2CO3. We have information of carbon dioxide gas at STP, standard at STP. 1 mole of gas occupies 22.4 dm cube. So we find out the N of CO2 by compared to this condition. The volume is 1.1 times 10 to the power of 7 dm cube over 22.4 dm cube times 1 mole. So you have the mole of CO2, then the mole of Na2CO3 we find out by comparing to the CO2. The ratio is 2 to 3. So the number of Na2CO3 is 2 over 3 times this, times X. After you get the mole, then you can find out the mass of sodium carbonate by multiplying